Okay, hi. My name is Constant Dullaart. That's a Dutch pronunciation of my name. I can talk with a very extreme Dutch accent. I'm very happy to be here in the Holy Temple of the ZKM, my final step to a very long journey, pilgrimage along everything that was important in the media art world. I think I'm finished now, so this is the final step, so I'm very happy that you can be here with me. I will now show you a video essay I made called Adversarial Dreams.
Candles make light by making heat, so they're crude examples of what we call incandescent lamps. Old-fashioned electric filament lamps, pioneered in the late 19th century by Thomas Edison, are a much more sophisticated version of the same idea. All the light a candle makes comes from a chemical reaction known as combustion, in which the wax, made from carbon-based chemicals, typically derived from petroleum, reacts with oxygen in the air to make a colorless gas called carbon dioxide. Water is also produced in the form of steam. Since the wax never burns perfectly cleanly, there's also a little smoke produced. The smoke is an aerosol, tiny particles of solid unburned carbon from the wax mixed in with the steam, and it often leaves a black carbon deposit on nearby walls or the ceiling above where the candle's burning. The steam is made in the blue part of a candle flame, where the wax burns cleanly with lots of oxygen. The smoke is made in the bright yellow part of the flame, where there isn't enough oxygen for perfect combustion to take place. The mental action or process of acquiring knowledge and understanding through thought, experience, and the senses, encompassing processes such as knowledge, attention, memory and working memory, judgment and evaluation, reasoning and computation, problem-solving and decision-making, comprehension and production of language. Human cognition is conscious and unconscious, concrete or abstract, as well as intuitive, like knowledge of a language, and conceptual, like a model of a language. Cognitive processes use existing knowledge and generate new knowledge. We know this, so we are. We think and therefore share this idea of cognition on crowdsourced information reference systems. Can we make we grow beyond we? You know what a candle looks like. You have perceived candles, piercing through human darkness, incandescent classification, interrelated percepts, introducing simulated concept landscapes, aligning simulacra by way of seeing what we wanted to remember. All these pictures you took and want to refer to will be referred to for making weakly deterministic descriptions of reality inseparable from the actual. That is life, or you. Do you see the candle? Not just your own candle, or the candle of your childhood, but the idea of any candle. What would a generic candle look like in your dreams? An object compiled from memory. Can we take the collective memory dump and read it thousands of times per second? NVIDIA graphics cards generating teraflops of power to train on what we saw before. If we all collectively imagine a candle, what would come out? Thousands, millions of images of conversations, social relationships, health, design, wealth, culture. Is this what we dream? Reverse what they understand of us so far. A cold machine, like interpretation of what we prefer to see. What do we depict when representing a restaurant, fire, a refrigerator, or a handkerchief? Associative for us, but a strongly determined model for the deep domain. Obfuscating the paradox of understanding. Welcome to the deep epoch, executing a transition function, crying for adversarial nomenclature, interfacing concept spaces to share between cultures, creating new pastures. A collective visual consciousness, learning to recognize the gradients, saliency, angles, curves, and hues of every visual concept we can just imagine. Monuments of cognition, copied to representations we can only dream. The beautiful imperfection of illustrating the grasp of a concept, the failure that induces a sense of authenticity and relatability, anthropomorphizing by way of input visualization, So this is what translates of our culture to machine understanding at the moment. Rapidly developing, every month shows us new applications of creative labor learned to a machine. Every day, new interpretation skills are outsourced to a neural network. Security cameras recording to the cloud, feeding the network to learn what evil is based on statistics. We are outsourcing judgment and prejudice to facts interpreted by rules. It's not our decision. It's the network's decision based on learning from all the facts in the world. This is what a miniskirt is with machine eyes. Fields of skin and fabric structured to evoke a memory of earlier perceptions. A cold naivete piling up the raw gestalt of the depiction. Will security cameras have read all novels ever written in the world someday? Or will we keep seeing clumsy drawings of missiles, restaurants, faces, and cultural biases supporting institutionalized discrimination, dreaming of a reality documented by human effort? It's like reality is seeping into another brain, and we are just the dream. We are the floppy monolith in a fuzzy background, retracing humanity in mechanical versions of history. Within the current machine learning revolution, so-called convolutional networks can now recognize objects within photographic images. This might seem like a trivial addition to already existing computer and online service capabilities, but it is a crucial step in how humans can interact with representation and depiction, addressing percepts, simulating mental sequences, while we are stuck addressing meaning with hardware running without proper code revisions of the genome. We see with 10 gigabyte per second, our core brain running on 500K of code, booting to about 75 megabytes, dealing with 5 million concepts in a lifetime, about 100 times more percepts. We are now outsourcing this to increase our agency by way of data compression in our brains. We are now outsourcing this to increase our agency by way of data compression in our brains and massive render farms, linking the newest NVIDIA graphics cards, calculating perception as mathematical models, enhanced agency differentiating by way of deep learning. A cow from a horse, for example, is now, in 2016, rapidly developing into recognizing specific people and their moods and interpreting behavior. Expediting these interpretations to learn patterns of recognition in the convolutional networks has complex ethical implications in need of urgent political discourse. We only perceive 2 terabytes of data in our life. We need to see more. First developed by Jan LeCun, now director of AI research at Facebook, based on the idea of the neocognitron concept of Kunihiko Fukushima from the 1980s. ConvNets have taken a giant leap forward with the availability of enormous GPU, graphics processing unit, power produced by NVIDIA, Latin for Envy, Corporation. Andrej Karpathy, Stanford and now research scientist at OpenAI, describes it as follows. In summary, the whole training process resembles showing a child many images of things, and him, her, having to gradually figure out what to look for in the images to tell those things apart. Or if you prefer your explanations technical, then ConvNet is just expressing a function from image pixels to class probabilities with the filters as parameters. And we run stochastic gradient descent to optimize a classification loss function. Or, if you're into AI, brain, singularity hype, then the function is a deep neural network. The filters are neurons, and the full ConvNet is a piece of adaptive, simulated visual cortical tissue. Starting with noise, static, arbitrary pixel distribution, images devoid of content generated at random, we ask what looks most like a tiger, a monitor, or a pedestal, to emphasize trained image classes from the dataset, a cinema, a projectile, a prison. This means we naively synthesize the preferred inputs for neurons in neural networks via deep generator networks to see what we outsourced to the computer to perceive, like we are looking around a corner where we will never be able to see, searching for a new reward signal, hoarding what feels great, because we built machines to see it first, an economy of cultural interpretation beyond our reach, trading rewards against entropy, testing theories beyond our comprehension, beyond what we can disprove in our lifetime, without machines. The standardized interface to see the highly improbable is in essence our new culture, look beyond you, comprehend beyond us, and see the new shared us without the need to delete. Fountains of data, flowing from all of us in every direction, pumped by way of advertising. Dream these fountains, dreaming gas masks, iPods or refrigerators, the surreal vision of gymnastics twisting bodies, and spandex out of the noise of shapes, gradients, and color. Deep neural networks, DNNs, have demonstrated state-of-the-art results on many pattern recognition tasks, especially vision classification problems. Understanding the inner workings of such computational brains is both fascinating basic science that is interesting in its own right, similar to why we study the human brain, and will enable researchers to further improve DNNs. One path to understanding how a neural network functions internally is to study what each of its neurons has learned to detect. One such method is called activation maximization, which synthesizes an input, an image for example, that highly activates a neuron. In a way, these synthesized images, based on photographic representation, show a mechanized version of the collective consciousness of the Western societies that trained it. These current state-of-the-art synthesized images look quite painterly, very surreal, copying human sense of documentation and composition, rendering each visualized class a deadly but sympathetic rendering of the gestalt of the class in question. This mechanical depiction of a concept questions our understanding of depiction in general, especially when positioned within a time frame of rapid development of these convolutional networks, testing within the limits of finite resources. But the sheer amount of capital, cultural, historical, or financial talent, and computing network of Facebook, Google, OpenAI, and others are throwing at these developments does not suggest anything else when a future in which these techniques will be utilized and rapidly developed beyond this current painterly, even beautifully naive level. Most of these networks are trained on large scientific data sets, created in or for MIT, Stanford, or Princeton. Millions of photographs sorted on class, with frames around the objects, sometimes terabytes in size. The data sets are generated through voluntary image uploads on Google Photos and Facebook, organized by searches and refined by human labor. Training our new brain by way of cheap labor in complex working conditions. The anonymous cloud workers learning artificial intelligence, our limited human, yet intricate visual interpretation parameters, in exchange for minimal amounts of money which can be hoarded for power, instead of the more ephemeral qualities of dopamine that our own brains would have used if we would have not tried to outsource our brain. These implications of neo-colonial capitalism will be embedded in the source code our newly trained, deep-learned society will use. We are still extending our bodies, and the value of the labor used for this is often only addressed pragmatically. A certain cultural bias can therefore be assumed into the choice of images and the selection of classes. These images are organized in. Analyzing the choice of image classes reveals a male American gaze, 40 different sorts of dogs, cheeseburgers, and pizza, all cultural references shorting this technological development within a significant geopolitical context. The reputation estimates to analyze these cultural biases systematically requires social learning, access to multiple interpretations of how we, humans, can live life. In these circumstances, we can only look for the normatively right opinion, which cannot be confused with anything called true. By asking the networks to synthesize what they know, or draw the preferred input of an image class, some of these cultural biases and human representation preferences are revealed to us within our white cube context, overlaying 17th century colonial capital. Kate Crawford writes for the New York Times. In 2015, users discovered that Google's Photo app, which applies automatic labels to pictures in digital photo albums, was classifying images of black people as gorillas. Google apologized. It was unintentional. But similar errors have emerged in Nikon's camera software, which misread images of Asian people as blinking, and in Hewlett-Packard's web camera software, which had difficulty recognizing people with dark skin tones. This is fundamentally a data problem. Algorithms learn by being fed certain images, often chosen by engineers, and the system builds a model of the world based on those images. If a system is trained on photos of people who are overwhelmingly white, it will have a harder time recognizing non-white faces. End quote. The preferred look of a kitchen, the preferred skin color of people, the colors in a flag, reveal the source of the information these networks were trained on. Our new thoughts, informed by a dominant cultural illusion that hoarded all the dopamine, so it can even hoard all the imaginary dopamine in order to force group loyalty beyond discourse. Our instincts adopt the dominant opinion in our social environment, and the machines we build will do the same. Culture by allegiance. Build this new society the machines it deserves. See here our candle, our shared visual light of a new conscious dreaming in our hands. Lucid cinematic references approximating gestalt to confirm our sense of social belonging, fleeing irrelevance and loneliness, because we share the recognition and longing for the replicated outsourced cognition to be inhuman, to burn up to 1400 degrees centigrade, burn beyond our scope of ability, indefinitely. I see a dog star divin' at his magic, snatchin', keeps me up awake, go crystal crackin'. I can't wait. I can't stay. A candle. Gotta change my mind before it burns out.
Yeah, sorry for the obstruction of seeing the rest of the exhibition with this really long, dominant voice. I did try to encompass kind of a lot of different approaches in this lecture. I ended with a Sonic Youth quote about the candle and about the kind of a poetic reference to the candle. But that's just explaining the last bit. Thank you for your attention listening through this entire thing. Just a simple explanation of why I showed these two images next to each other is just because I wanted to have none of them be dominant. So actually it's showing the same image twice, but that means that it's more difficult to look at a single image and the detail of a single image because you see it twice. Anyway, so it's just a simple, crude kind of way of like trying to entice you to look at the concept of the image before you look at the detail of the image. And of course, there's different variations that I used of like visualizing specific classes. So in this whole thing, I visualized like the candle, but also refrigerators and restaurants and monoliths and rockets and these things. In all these kind of different variations that we trained the network on. These are, for example, this is a rendition of a candy shop. So the interesting part to me is that the network saw thousands of actual pictures of a candy shop before it could draw this, before it could understand the visual parameters that shape a candy shop, that it would recognize what a candy shop is, and then it could actually redraw it basically from memory. As soon as you give it the seed, like an abstract visual seed, it could redraw it. But then we did some other experiments, that was me and Adam Harvey, to also combine different kind of neurons or different associations together. So for example, here you have a weasel and a carton, or a toaster and a mailbag. So you have these different types of conceptual triggers. And if you confuse the two, you see which one is more dominant. But for example, packet plus jaguar, I think is quite nice. But there's sometimes sometimes even the association, because I just combined the random classes that were available in ImageNet, which is this visual database to train image recognition networks on. And sometimes the combination is quite logical, like bell pepper and cheeseburger. But sometimes there's a waffle, iron, and Pekingese, like the dog. Shovel and megalith. There's a few beautiful abstract paintings come out of just like kind of throwing these kind of visual concepts into a blender together. Spacebar and cardigan come out just as a typewriter. So you see that the spacebar idea triggers a typewriter, and that's much stronger visual preference than the cardigan. And I still think it's like to me, it's interesting that if you would see these apart just as an image or as a kind of an abstract painting, it would still work, just because it has a certain aesthetical preference. amphibian and pelican kind of looks like a sailing tank. Shih Tzu and nipple is kind of a strange association to put together. Pedestal and ice cream looks like a really beautiful, nice, dreamy artwork. I would love to have pedestals made from ice cream. Anyway, so there's like but this is also, and maybe that's also in the end the problem of like this entire topic and why that lecture was also so long, is that there's millions of outcomes of this. Like we can just regurgitate all this content in all these different forms, and it's actually quite hard to choose because in the end they all seem kind of aesthetically pleasing. So I'd like to show you one of the things that we developed in this process while we were trying to figure out the different ways, the conceptual meanings of like how these images are separated from each other, is that we developed a new color called dull brown. And dull brown is also a part of like the dull empire. And the dull empire started with dull tech. Well, it actually started with DullArt, which is my name, my birth name. And then I ventured into dull tech, like the boring technology. And then we made Boring Dreams, which is exhibited here, which you can upload images to and then make boring versions of your own images. And then we also found the most boring color that exists in the world. And this is actually the common color that you can derive from these data sets. So what basically in this technology is that if you take a reference data set, you take, for example, a class of, let's say, horse, you would look at the most common color in all these images, and then you would subtract that from each image. So you would take the mean, the obvious thing that's represented in each image, you would take that out, so it's easier for you to recognize what's unique in each image. And that's kind of interesting. You would do it in general. The human eye also starts to ignore what is there all the time, just like you filter out a certain sound that's there for longer than 20 seconds, or you filter out certain visual preferences that you just don't notice anymore because it's there all the time, just like with cultural presence. So what we did is that we applied that same technique to the biggest data set that's available, publicly available now, which is still ImageNet. We calculated that this is the most common color within the largest set of photography, reference set of photography that we know. And then basically this is just a text explaining that this color. So this to me now is like a color that I want to use in everything. It's kind of a strange fascist color, I guess, but yeah. Fine. Anyway, so dull brown. I guess it's also dull gray. And I also wanted to show you, so where I previously, where we created this Euronet as like a unique new data set to reference European culture, where we found clearly that European culture was like abundantly represented by cheese. Even the Colosseum looks like cheese here. So here, with this kind of illustration, you see clearly the technique that we used is that we start with a random seed image, which is basically an abstract image, and then we ask it to, in this case, this is camembert. So we basically we give it an abstract image, and we ask it to recognize camembert in that image. It would initially say this is 0.1% likely to be camembert if it analyzes that image. And then we ask, like, what happens if what needs to change for you to be, let's say, 2% convinced that this is camembert? And then we'd say, like, well, these lines need to be somewhat different, this color needs to be emphasized, that needs to be like that. And then we slowly increase the amount of confidence that the network has that this could be camembert. So it actually draws camembert from noise, from an abstract noise, it draws what it thinks it would need to be convinced that this is Camembert. And of course, we can do this a million times with like all these different source images, and every time it would make new iterations of Camembert. And this is a very strange creative principle to think of, like drawing an object from memory, but then basically just constituting or like manipulating an image until it confirms your idea of a certain concept. So these are, for example, the Lascaux cave paintings. So we fed it all the different images that are available to the paintings of Lascaux. And Lascaux, of course, is interesting because it already exists as a reference, as in that you can't visit the original anymore. You can only visit the reproduction of it if you try to visit it, because for safekeeping, they needed to enclose the original. So this is interesting that it already lives by reproduction. It's only visible by a reproduction of it. And this is using all the photographic reproductions of it. And what I liked about these kind of iterations is that you see not only the artifact of the stone and the artifact of the person that drew it, but you also see the artifact of the JPEG that recorded it. You also see the artifact of the network that actually reimagined the same type of drawing. Yeah, so you get these kind of iterations of that concept. And to actually train these classes, or actually this recognition, we needed to find ways to deal with thousands of images. So we actually also used these after a while we made these instructional videos for all the outsourced labor that we used. So me, my partner, but also several assistants, but also a lot of outsourced labor in Pakistan and India and the Philippines were instructed to analyze all these images. So this is the images of Theresa May. So they were instructed to make these annotations of what is Theresa May in the image. And they needed to make a square crop of it. So we needed to make these like quite simple instructional videos of showing them how to focus on Theresa May. Most of them were really good. But for example, this crop could have been smaller. Is there this announcement that the exhibition is closing? The exhibition is closing in 10 minutes. Okay. Anyway, Theresa May doesn't always look happy. This was obviously a wrong crop. This is a crop top, but the image was wrongly cropped. Now she looks nude. Anyway. So let's go through Theresa May. So this is the result. So all these images that were fed through, but this is, I just wanted to explain that it becomes this abstract because it's trained to compare itself to other objects, like all these cheeses and the croissants and these other things. So it's not trained on humans. So it's kind of a strange abstract outcome if you start to look at human faces and compare them to other objects. They start to become these really crude versions of what a face would be. And they become these kind of strange Francis Bacon-like representations of what humans are. But this is also interesting to analyze an artistic process already, to see like maybe Francis Bacon was looking at people like they were objects. Anyway, then I would like to end this brief talk, because the exhibition is closing soon, with, it's strange to hold the microphone and do this at the same time. Let me like this. Yeah, I'll do it. So in this exhibition, so if you've seen it already, there is a version 1 of DullDream, in which we took the entire image and we analyzed what was interesting in the image, and then we tried to make it conceptually less interesting. So dull, made it boring. We tried to remove the object hood of what was represented in the image. And there's about 1 million ways to do that conceptually. And we just launched another version of that, in which I'll show you the recent images that were fed through that network. And this is one I've done earlier, and where you see that the background is now still in place. So the background, and it's just altering and redrawing the object that it recognizes. Still, very often doesn't really work. So it's like a visual virus taking over the image and taking over the representation. But here it kind of works. It goes to like a somewhat representation of a face. It's stronger in the facial features. I think it's quite remarkable that it kept that up. And if you upload an image, so we should maybe find a nice image. I will find an image of my dog and cat when they were still a puppy. So you see that it's going through the Amazon server. So I'm happy that they're there and I'm sad that they're there. So the smile is turning into a frown. So yeah, sometimes it works, sometimes there's a different. So I could do this multiple times, but you can click on the detailed analysis, and this is the segmentation. So this is like separating different values of the image, and then it's asked to basically separate that again into itself and then redraw it and then overlay it onto the original image. So there's still about 1 million ways to make to analyze what is interesting in the image and to make that more boring or less significant. The original version of DullDream does it slightly differently. I hope this wasn't too loud so I didn't disturb anyone viewing any of the other works. I tried to whisper a little bit. Yeah, so also it's strange that the costs of these servers are quite significant. So, and sometimes, anyway, so here it takes the entire image and it turns it into a kind of a stronger abstract. And here it really looks at doesn't separate the objects, but it just looks at like the saliency of the image. So the saliency is like, where's the concentration of what is interesting? And it's kind of interesting that it finds a region here at the face, and it finds this kind of interesting, which is basically true. That's where the interesting parts of the image are. And then it takes that as it minimizes that and then redraws it. So these are different techniques of like trying to find what is interesting in the image and making that boring. But the problem, of course, there is that the infrastructure to do so in itself is already interesting again. And then the result of that also becomes interesting again. But maybe we make the paintings of Francis Bacon less interesting now by doing this, by mechanizing this. And I will maybe leave you with enough time to leave the building before we're on lockdown. And thank you very much for your presence. And if there's any questions, please let me know.
I would like to thank you for your presentation, and I would like to apologize in the name of the Holy ZKM for its visitor who was kind of rude and unpolite with you. I would like to ask a very short question. If it's the last station of your pilgrimage as a computer-related artist, what is your next life goal? Very short question.
Yeah, I really don't know. I really don't know. I'm very confused at the moment. Yeah. Saved by the Bell, too. Any other questions? Thank you.